Imagine being able to see the components of a potentially dangerous situation in live 3D and with fine detail without even having to send a human to survey the area. It's possible, and that's one of the reasons why experts from the Air Force Civil Engineers Center are asking industry leaders to showcase the capabilities of LiDAR mounted on various robotic and small unmanned aerial system platforms. Welcome to another episode of High Technology. Join the club as we unravel high-end technologies on the planet by subscribing to this channel and hitting the notification bell so you won't miss any exciting videos in the future. Today, let's see what this LiDAR robot has to offer, and could it be the future of military robots? Their LiDAR is short for light detection and ranging. It's a remote sensing method that uses light in the form of a pulsated laser, a scanner, and a specialized GPS to measure variable distances. When LiDAR is paired with other advanced technologies like small unmanned aerial systems or unmanned ground systems, a robot dog for example, the warfighter can view and create a digital twin model. We can transmit a pulse of light, bounce it off an object, and then measure how long it takes for the light to return, since we are aware of the speed of light through our environment. We can calculate the target's distance by having the total time and multiplying the result by the speed of light. This is how LiDAR functions at its core. You take the pulse of light and reflect it off a rotating mirror to gather more information about the surrounding shapes. All of these data are obtained as the laser revolves around the LiDAR, creating a flat plane of measurement. This plane of measurement can be stacked with succeeding planes to produce a point cloud, which is a type of three-dimensional map. A few benefits of LiDAR technology include its high accuracy, high resolution, and extensive detecting range. Because of this, it is beneficial to utilize in many applications. In 1930s, searchlights, photographic paper, and a telescopic lens were used to develop the first LiDAR system in order to gauge the size and density of clouds. Based on that idea, Hughes Aircraft Company developed the first LiDAR prototype not long after the laser was created in 1961. Its original purpose was to assess air pollution and clouds while tracking satellites. The American space program employed the technology to survey the moon's surface during the 1971 Apollo 15 mission, which helped the technology acquire popularity. Since then, it has been put to use in a wide range of applications in different sectors. LiDAR is still being used by NASA to map the topography of the Earth and analyze climate change. It is used by archaeologists to produce incredibly detailed maps for surveying. Even in the entertainment sector, technology has been utilized to produce 3D images of towns and structures. You might even carry a LiDAR device with you. For augmented reality apps, the most recent iPhones contain a tiny LiDAR sensor. Dr. Erwin Sick, the inventor of SICK, a global provider of intelligent sensors and solutions for industrial automation technology, employed light or light-based range as the first industrial use to make machinery safe. His mission was to use technology to make the world a better place and to make people's professions safer. Since then, the technique has been applied in a variety of manufacturing and industrial situations such as robots and machine safety. In the past, a controller received a large amount of data, processed it, and then used the results to take action. Many people lacked the finances or didn't see the benefit in taking on such a project because it was complex. To make LiDAR easier to use, however, we have introduced more tools and functionality over time. This has made it possible to extract extremely useful data from manufacturing processes. Today, a lot of our LiDAR systems include built-in configuration tools that streamline and simplify setup. Several versions of LiDAR have been developed since its creation decades ago for a variety of industrial applications. There are three typical categories. This kind of LiDAR takes the shape of a small, light laser scanner. As they are often employed for straightforward area monitoring activities, these are regarded as entry-level technologies. Thanks to 6 high-definition distance measurement or HDDM technology, sensorized LiDAR solutions work effectively even in bright environments. This makes LiDAR detection less expensive and difficult. Although this kind of LiDAR is increasingly employed for fundamental applications on the production floor, it is also used in some autonomous car applications. In order to detect the presence of objects that shouldn't be there, such as an overstuffed bin or a bag with goods emerging from it, the LiDAR sensor produces an invincible plane of detection. This is a very helpful in a production and packaging setting. Sensorized LiDAR can be employed in pass-through detection and bin picking applications. This enables producers to keep an eye on product and production and guarantee quality. The technology will alert the operator if they reach into the wrong bin. Historically, this was often done with multiple light curtains, but a single LiDAR device is much simpler simpler to install and wire. A single LiDAR device is far easier to install and wire than several light curtains, which were frequently used in the past to do this. Others refer to it as multi-layer or multi-channel, while some call it 3D LiDAR. Unlike 2D LiDAR, this type of LiDAR offers 3 additional planes that gives more detection. This can be used to find objects that are far away. A layer of detection that is not provided by 2D LiDAR is added by additional planes. For instance, another aircraft might pick up the object if it isn't properly aligned with the plane. This provides more flexibility so that a multi-layer sensor can adjust to conditions when objects are not perfectly aligned or constantly in the same place. In a packaging setting, detecting pallet overhang is a frequent use for multi-layer LiDAR. Pallets can be scanned with it to check for any objects that shouldn't be there. Additionally, it can make sure that the pallet is organized and that nothing is protruding that could catch on machinery, pierce, stretch, wrap, or otherwise interrupt the line. Due to its several layers, it may even take partial vertical pallets into consideration. Solid-state LiDAR is another type. This kind of LiDAR gives users a camera view of all its scans as opposed to the previous 2 types, which used a single plane or many planes. With the use of this technology, a 3D image that goes beyond an image is captured off the surroundings. Additionally, it offers the depth or distance corresponding to each image pixel. Many AMR applications can make use of this kind of LiDAR, but it also functions well in other settings. LiDAR, for instance, may provide a 3D representation of whatever is in the bin for bin picking applications, enabling the robot to know what and when to pick up. The dimensioning of packages for pallet loading is a last application. It is a typical practice in pallet loading to gather many cartons and put them on a pallet using a robot suction gripper. The robot can now assess the position and size of the carton by adding LiDAR to the end effector, allowing it to dynamically adjust its grasp and increase efficiency while minimizing errors. The camera is simple to install, immediately operational, and delivers reliable high-quality 3D data in a single shot. LiDAR technology has many uses across a wide range of sectors. LiDAR technology has developed in industrial settings to the point that manufacturers may utilize it in ways they never imagined. One such example is the use of service robots. Increased automation is visible in both daily life and production and manufacturing settings. In hospitals, onboard cruise ships, and retail stores, at airports, and in hotels, service robots are already doing a variety of activities. Both for industrial use and now for personal use, robots are booming. Service robots in banks and other businesses can hand out flyers, amuse people who are waiting in lines or lobbies, and inform potential clients. Robots in the travel sector do part of the duties of the staff, relieving human workers. Service and security robots use the 2D LiDAR to detect every element of their environment and dynamically adapt to changing circumstances so they can interact with people and respond to unanticipated scenarios just like a person would. Indeed, the users for the LiDAR in unmanned systems, platforms, and technology combination in the civil engineer community are almost endless. What do you think about these LiDAR robots? Could these be the future of surveying equipment in the military? Let us know in the comment section down below. That's a wrap for now. If you enjoyed this content, please don't forget to like and hit the subscribe button and turn on the notification bell so you can always get to watch more incredible videos like this. This has been High Technology, serving you the best and cutting edge contents on the highest form of technology available on the planet. See you on the next one.